Hello, everyone, and welcome to today's webinar. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You have joined the presentation listening using your computer speaker system by default. If you prefer to join over the telephone, just select telephone in the audio pane and the dial-in information will be displayed. You have the opportunity to submit questions to today's presenters by typing your questions into the questions pane of the control panel. There will be 3 separate question periods, so please get your questions in during the videos themselves, and we will collect these and address them during the 3 separate Q&A periods. Today's webinar is being recorded and you will receive a follow-up email within 24 to 48 hours with a link to view the recording. And now I'd like to introduce Sean Hargett, Steeger's president and event moderator.
Thank you, Tracy. Good morning and welcome to our webinar, 3 Key Insights on Creating World-Class Braided Shafts. I'm Sean Hargett, President of Steeger USA. Over the past 25 years, Steeger USA has continued to refine its braiding equipment for the needs of the medical device industry, including partnering with Machine Solutions 7 years ago. During that time, both Machine Solutions and Steeger USA have purposely brought into the Machine Solutions family some of the most trusted brands in the catheter manufacturing and testing equipment space. Today we have 3 experts from our Steeger USA team with us to discuss different aspects of braided shafts and the parameters around them. These experts are Paul Hazaras, Boris Copeland, and Will Huey. Each of them has a specific presentation, and at the end, we have set aside time to answer questions. Please hold your questions till the end and/or put them in the question box, which I will be monitoring during the presentation for us to discuss after. With these formalities out of the way, let's get started. For our first presentation, I would like to introduce Paul Hazaras, East Region Braiding and Laminating Sales Leader. Paul has been with Steeger USA for over 11 years. He has spent time on all of our assembly teams building our braiders from the ground up. He led our R&D lab for 5 years, working directly with customers on all types of applications. Currently, Paul covers our East region from a new equipment sales perspective, focused on braiding and laminating, both of which are critical to the topics being covered in our webinar today. With that said, Paul, here you go.
Hey everyone, Paul here with Machine Solutions to give you an overview of the 2 styles of braiders that we manufacture here at Steeger USA. The first one is the vertical braider. Hopefully this overview will give you as a customer a good understanding of why you would choose a vertical over a horizontal. So we'll run through the vertical and hopefully you'll be able to get some good content out of this and be able to understand what the vertical is going to do for your product. So we'll start at the capstan. We have 2 options for the capstan. First one's going to be a flat capstan. Works great for tubing and large OD core material. And then the groove capstan, which is great for your smaller OD core material, or if you see that the braid material is slipping on the flat capstan, you would want to go with the groove capstan. Moving on down to the braid formers. We offer custom braid formers to fit a lot of different size ODs and a lot of different materials. We also have different carrier options for this braider. You have the KL80D carrier, which you see here. You also have the KL4000 carrier, which is a great carrier for fiber braiding. We can also increase the diameter of the horn gears on this braider to accommodate a larger carrier so that you can get volume if that is what's needed for your braid run. The vertical braider in itself has a very great footprint for a lot of customers as long as you like reel-to-reel applications. If you're braiding reel-to-reel, this is the braider for you. We can also increase the spool capacity on this braider to up to 20 inches in diameter. We also have a torque motor system that can get put on here if you need that fine-tuning of the take-up system and the payoff system. The carriers, the tensioning on the carriers, we can have different roller setups. We can have different eyelets that get put in place to really help with the wires that are paying off of the carrier. We will help either through the lab or through the training to get your materials dialed in on the carrier so that it's laying down in the pattern that you need and the density that's needed. The control package on this braider is going to come with an IMC Allen Bradley system. This is going to allow you to have a variable density braid run with multiple segments if needed for that complex catheter braiding product. So you can program this braider with up to 25 different segments, and it holds up to 99 recipes. So you'll be able to have a push button solution here to run specific parts through this braider on a reel-to-reel application. So that's the vertical braider. Let's go check out the horizontal. And now over to our horizontal 16 carrier. Some cool new features about this is our new IMC Allen Bradley system. It's the IM7. This is going to give you a more response time to your start and stop of the braid. You're also going to have really nice push button keys, and this will allow you the same as the vertical IMC. You'll have the recipe management with the 25 segments along the shaft, or the reel-to-reel application for this braider. You also have a new light tower on this one. So the flexibility, I want to speak a lot to the flexibility of a horizontal system so that you understand, is the horizontal the right one for me or the vertical? So with the horizontal, you're going to have the flexibility to braid reel-to-reel or discrete pieces. A lot of customers that are starting up, this is a great braid if you don't know exactly what you're going to be getting into with the catheter braiding. So you'll allow, or the Whittles Albert will open up and it will allow you 8 millimeters of OD. If you need to go any higher than that, you want to go with the Versa. Our Versa will allow you 50 millimeters of OD for your product to go through. On the take-up side, we also have the torque motor system available with this, or the Dancer. And some customers, if they're just braiding shafts, they're going to have the feed tray that will replace this system here, and it will allow you to just lay your product in a tray. You can actually use both ends to have a feed in and a feed out tray once it comes out of the puller. If you need this automated, we also offer a pick and place system, and a lot of customers like that. As long as the volumes are high and it makes sense, the pick and place system for picking up discrete pieces and braiding them is the way to go. So on this system too, you'll have the capability of going with different carriers. You'll also have the flexibility of having the larger horn gears if you need to go larger with size. So this will have the same head flexibility as the vertical unit. And the other great thing about this that we've just started ramping up a lot is our new modular system. The modular system is going to allow you to have a 32 and a 16 carrier head together, which is a great startup for a lot of the customers that we're seeing now that are getting into most of the catheter braiding. I'm going to let Forrest speak a lot more to the modular unit and what we offer with that.
Thank you, Paul. Appreciate the information shared there, and want to take a few questions now discussing the horizontal and the vertical machines. To start out with, talk a little bit about which of those styles of braiders has the most flexibility for current and or future braid development for customers' applications.
Absolutely, Sean. The horizontal is going to be the best machine for customers that are needing that flexibility in their braiding and R&D development, or if they know down the road that their product OD might change, or the braid material itself could change a little bit. So the horizontal, definitely from a flexibility standpoint, is going to be the best braider for that.
In talking about some of the uses for the vertical machines, which types of applications tend to lend themselves best for the vertical style of machines?
Vertical style is going to be reel-to-reel applications where customers are needing large spools or small spools to be braided in a continuous manner. You can have spool sizes up to 24 inches on the vertical. You can also have larger spools if needed, but that would be on the horizontal. But up to 24 inches, we're able to kind of tuck underneath the vertical braiding platform using our torque motor system. And depending on the size of the core OD, it should fit well with the the continuous spooling of the vertical system.
Are there certain, one of the questions we've gotten, are there certain standard spool sizes that machines are typically set up for? And what about spool sizes that would be smaller than those standard spool sizes that our team routinely sees?
Yes, normally it's usually a 12-inch spool size is our standard that we use on, I would say, 95% of our braiding systems. We have gone smaller down to like a DIN size if needed. So we've accommodated smaller spool sizes down to what you would get from a wire manufacturer, a DIN 100 or a DIN 200. Somewhere in that small size range, we're able to tension the take up very precisely on those. And we would just have to talk through that with customers. But yes, our machines are flexible to go down to as small as like a DIN 150 or DIN 160, and then up to the 24-inch spools if needed.
So those same spool sizes would be able to be used on a horizontal machine or a vertical machine, assuming a customer may have some of both.
Yes, it would. So we can add that flexibility into either system, horizontal or vertical, depending on what the customer's needs are and how that material is going to be braided. And we would work specifically to make sure that those tensions are dialed in on both sides of the machine.
Okay. Let's talk a little bit about the horizontal machines. A couple of questions that we have coming in talk about the benefits of the dancer versus the torque motor take-ups. And then as part of that, if you can discuss maybe some of the OD ranges that typically play into both of those, or some of the things that we look at in choosing what's the best option for our customers in regards to the take-up options.
Absolutely. So on the dancer option, that's usually our standard offering. And as long as the customer's core material likes that bend radius or allows for a bend radius while braiding or being taken up, then the dancer is going to work perfect. It's with the customers that have either a rigid core material or a stronger plastic material with the core that the torque motor system really shines for that customer, because it's being taken straight up from the puller onto the take-up spool, and it just allows for an easy take-up system. And the customer can also control the amount of torque that's being applied to that take-up system, and it helps that product at the end on the other side, any post processes. So the dancer is good for flexible core, and if your product likes that, and if it's not, it's more of a stronger core, I would definitely go to the torque motor system. As far as the ODs go, we have two size pullers that we can offer on the horizontal system. That would be your Whittles Albert. It can go up to 8 to 10 millimeters maximum, and the Versa puller is going to go all the way up to 50 millimeters, which is roughly 2 inches of OD, and both of those can go down to nothing. So just your braid wire itself can get braided in there with no tube. Both of those puller systems can handle that. You're just getting a little bit more OD and more flexibility with the Versa system. The Versa system does pull a little bit stronger, so if you're using a high tension braid, or if you need to have high tension coming through your carriers, then the Versa puller is definitely a little bit stronger. So that might be something that a customer would be interested in.
So just to confirm, one of the questions we had in the chat box was the smallest OD that the horizontal machine can braid. So talk a little bit about that, but I think you said that, if we were putting essentially, single wires into it to braid over that, then that would work, assuming they were tensioned well from the payoff side of the machine.
Absolutely. So there's customers that have no core at all. That would be a coreless braid. It's what we call coreless braid run. You're essentially just braiding some of your material together to create a braided mesh of some sort, and it will pull through the puller with no core. And there's customers that use the same material as their core material with the braid material. So you're actually braiding over the top of your braid material, and the puller system has no issues pulling through the same material with your braid.
You talked some about the differences in the Whittles Albert and the Versa. As far as upgrading or changing things on a machine, a question we received is, can a customer easily swap from a Whittles Albert to a Versa within a certain size horizontal machine?
Yeah, that's a question that comes up a lot, and it's one that over the years we have talked specifically through with customers just to make sure that we're selling them the right puller, because it's not something that is easy to perform. The machine usually gets shipped back to Steeger USA for something like this upgrade, and if you are hesitant on the Whittles Albert, I would suggest to go ahead and get the Versa, just to have that flexibility and not have to worry about upgrading in the future, because it's a pretty extensive upgrade, and we tend to talk through customers, with a purchase to make sure they're getting the right puller size in the beginning. Can it be upgraded? Yes, absolutely. It would just take a little bit more time, and usually the machine gets shipped back to Steeger.
So in your presentation, you talked some about variable density braiding, both the control system and then some of the transitions and that kind of stuff within the control system. Talk a little bit more about that, in how many times the customer can change that, and what some of those transitions can look like, those kind of things.
Absolutely. So the Allen Bradley IMC control package that comes on our braiders will allow customers to store up to 25 segments within a single part. I think it's up to 99 recipes that you can store, but 25 segments within a single part. And it's really just customized to that specific part. We have customers that want that try to do an instantaneous change, and we can work with you on that based on the primary and the secondary. We can do our best to get that transition as instantaneous as possible. There's also customers that are braiding over different ODs with their mandrels, and we have to control the density based on the OD change of the mandrel. So there's capabilities there. The machine is and the puller are talking to each other, and we will work specifically with that customer to make sure that the density is right. And then also the recipe gets stored in there, so when the customer does purchase the braider, it's a turnkey solution. They're able to have those recipes stored in there, and we work with them specifically through the lab or either through the FAT training during the purchase.
Great. So talk a little bit about, as you work with customers that are either just starting to braid or just looking at new product applications, and have some information, but that information may be limited. Kind of, talk to this group about what the process looks like as you're discussing those options with them and helping them determine what might be the right both carrier count and type and style of machine for them as they're looking to get started with a new application or started with braiding.
Absolutely. So number one, we'll talk through those ideas with them. We'll try to put them in a carrier, a braider selection on where we think would be a good fit based on the materials that they're looking to braid with, the OD, and what their actual goals are, what their characteristics that they're looking for with the braided shafts. If they have any kind of idea with that, then we would start out in our R&D lab here at Steeger USA. That's the number one spot for dialing in the samples, dialing in the specs that are needed, and what your ultimate characteristics are there, and the goal that you guys are after on creating a specific shaft or creating a specific braided part. Our lab has a wide range of braiding machines, and I point customers there that are just starting out, that have no braiding knowledge at all. They are more than welcome to come down here and work with Forrest and Ben. We host a lot of customers through there, and it's really beneficial for them to actually see the machines running, and then also to touch and feel the parts that are coming out of there, to see the characteristics that they have. So I would, number one, point them in the lab, just to get the customer around the size machine that they think would be beneficial for that part. And then we would just kind of work through everything there to dial it in. That's usually the route that I would take with a new customer.
Paul, thank you for your time. Appreciate you answering these questions. I'm sure we'll have a number of others that come up, and look forward to you taking the time to discuss those with customers as after the webinar and following up on a number of them. So, thank you.
Yes, sir. Thank you, Sean. Thank you.
Next, I would like to introduce Forrest Copeland for our next presentation. He will be discussing braid patterns. Forrest is our R&D lab manager. He has been with Steeger USA for 6 years, spent time with our assembly teams as a technician in our lab, and for the last 3 years has led our R&D team. Forrest is working daily with engineers, developers, and operators using our in-house machine solutions and Steeger USA equipment to assist them with refining their current products and developing their next generation products. With that said, let Forrest take it away.
Thanks, Paul. Before we get into the modular systems, though, I first want to explain the braid patterns that our machines offer so that you can get a better idea of the reasons why you would need a modular system. Understanding the characteristics and functionality of the standard patterns of a Steeger USA braid machine will increase efficiency in research and development, which will save time and money. Steeger USA is widely known for its maypole style braiding machines. The word maypole comes from the maypole dance, a ceremonial folk dance performed around a tall pole garlanded with greenery or flowers and often hung with ribbons that are woven into complex patterns by the dancers. Steeger USA also manufactures flat braiders, square braiders, spiral braiders, stranders, and coilers. The first pattern I'd like to talk about is the full load regular pattern. The word regular is because it is the most commonly used pattern. The reason for that is because it runs at 100% capacity of the machine. The machine runs at one pick or one revolution per pick. So the horn gears turn one revolution per pick. The pattern is 1/2 under 2. And this pattern is known for its throughput, like I said, and also the flexibility. It also has a good resistance to elongation, which plays a big role in break strength when pulled. The next pattern is the full load diamond pattern. The full load diamond pattern can be considered the opposite of the full load regular in the sense that the throughput is twice as slow. So where the full load regular pattern has one horn gear, or the horn gears turn one revolution per pick, the full load diamond, the horn gears turn 2 revolutions per pick. The pattern is 2/2 under 2. A common thing that'll happen with customers when they come to me with a request and they tell me a 2x2 pattern, I'll always ask which one. And the correct way to say it is a 2/2 under 2 or a 1/2 under 2, just to help us clarify. But the full load diamond pattern is a very useful pattern. It's great for providing full coverage. One of the reasons it provides good coverage is it's also using twice the amount of material. So if you set up 2 machines next to each other, one's the full load regular, one's the full load diamond, because of the horn gears turn in 2 revolutions per pick, it's also using twice the amount of material to accomplish that pick count. It's because of the extra revolutions. It's a much sharper braid angle as well. So if, for example, in terms of throughput, if it takes the full load regular pattern machine to 10 minutes to complete the braid, it'll take the full load diamond 20 minutes. If you use 100 feet per bobbin on the full load regular pattern, you'll use 200 feet per bobbin on the full load diamond. That's if the pick count, the setup, everything else is the same. That's how comparable it is. It's the opposite of the full load regular in that sense, also for flexibility. It's not known for flexibility. It's known for its stiffness and rigidity. So, it does have good radial force and compression strength due to some of those variables, but it's typically used in things like an endoscopy. I see it a lot in endoscopy. But yes, the full load diamond pattern is twice as slow, uses twice the amount of material. So from a throughput standpoint, from a cost standpoint, it's not the most ideal pattern, but can be used for good coverage and if you need that stiffness and rigidity. The half load diamond pattern is the third of 3 symmetrical braid patterns that our machines offer. And I like to say that this one is the best of both worlds. It has the good radial force strength and compression strength, kind of like the full load diamond. It's also just as slow as the full load diamond. It also runs at 50% capacity of the machine, 2 revolutions per pick. But it also has flexibility, just like the full load regular. And actually, I would probably say better than the full load regular in one sense, because it provides a better kink resistance and torque ability and push ability. So when going around curves in the vanes, less likely to kink. And I think that has a lot to do with the way the pattern comes in. So it's one fiber of wire over one under one. And so it kind of interlocks itself. We oftentimes compare it to like a Chinese finger trap. So a lot of times, and I'll explain further when we get into the modular systems, but there's a big reason why customers start out using the full load regular pattern and then they transition to needing the half load diamond pattern. But that may mean that they need another size machine. Here is a picture of the half load. There's actually 2 different ways to load the half load pattern, but this is just a picture of what it looks like on the machine. And in previous slides, you could see that you can see the same pictures for the full load regular and the full load diamond. But this just kind of gives you an idea. When you walk up to the machine and you see the carriers, you can tell that there's a lot of gaps on the machine. That should be an immediate tell sign that the machine is in the half load pattern. And now to the modular systems. Steeger USA modular braiding machines provide flex manufacturing capacity and are designed for research and development opportunities. The modular machine frame utilizes the same footprint as our standard horizontal 24 and 32 carrier machines. This newly designed machine can accept an 8, 12, or 16 carrier head with very little floor space required. Modular machines' simple bolt-up, plug and play design requires minimal changeover time for operators, R&D groups, and equipment maintenance teams. So you can see you have the opportunity you could purchase multiple heads and only have one puller station. So if you look at the picture on the right, you can see that one of the heads is connected, and then you can see 2 other heads that can be purchased alongside with the machine that can be changed over. So this gives a customer that's, lacking floor space, but doesn't really need a vertical machine, because vertical machines are more for reel-to-reel applications. It's usually for an application that you already have figured out, that is something that you just want to run lights out, 24/7. Horizontal machines are normally for R&D type work, and having the multiple heads and only one puller station is very helpful, because that's always been one of the things that customers did not like about the horizontal machine, is because it does take up a lot of space. But at least with this option now, with being able to purchase multiple heads, you are reducing space, because if you see the picture on the right, that would normally be 3 different machines, and so taking up way more floor space. But if you're only using one of the heads at a time, you can roll the other ones out of the way to a corner in the room or whatever you need to do. In the catheter world, most customers start the production of braiding catheters with a 16 carrier braid machine in the 1x2 pattern or 1x2x2, because it has the fastest throughput and has all the characteristics needed to a limit. What I mean by that is, the full regular pattern does have radial force strength. It does have compression strength, just maybe not as good as the half load diamond pattern or the full load diamond. As customers begin to push the limits of their catheters, they discover they need to try something else to increase those things. And, a lot of times also the customer wants to have the same number of wires. So in this case, start out with a 16 full load regular pattern, which is most of the time what happens with customers in the catheter world. They'll end up wanting 16 wires, but they want that better radial force strength, kink resistance, torque ability, compression strength, etc. So they go to a 32 half load, which is still 16 carriers, still 16 wires, and it allows them to basically, the only thing in the design that's changing is the pattern, and they were able to increase the capabilities of their catheter in multiple ways. So my name is Forrest Copeland, and I'm the R&D lab manager. Here's a picture of our lab here on the left, and this is just a slide to show you our capabilities. We make samples, run trials, research and development, long-term consulting, short production ramp up. We have a lot of machines in the lab: 8, 12, 16, 24, 32, 36, 48, 64, and 96. We also have a stranded machine that can do multiple sizes, 3, 4, and 7 design configurations. We can also do coiling and spiral wrapping. We offer bobbin winding, and we also sell winding machines, just so you're aware. We can do heat treating. We have a oven, a furnace that we can use, mostly used for heat setting nitinol. We have an MSI VL400 laminator that can be used for customers that are needing to heat set jackets over their catheter braids. And we also have a modular clean room for clinical samples. I do want to give a debrief for that. That clean room is a clean room. It's based on what's comfortable to the customer. It is not certified, but we've had multiple customers that have been able to make do with it to get their project to a certain level before they could purchase capital equipment and bring things in-house. So like I said, we have a lot of toys to play with, and I am at your beck and call. So please take my email and that phone number there. Give me a call with any questions that you may have, any opportunities you'd like to bring forward. We are very flexible. We are able to modify our certs and material certifications, our packing slips. Our entire quality system can really be manipulated to whatever the customer needs. And we also highly encourage customers to come out and visit with us, work with us. It allows us to make changes on the fly, prevent you from spending more money than you need to, and allowing us to find a solution a lot faster. We hope that you take full advantage of this, and that this will help you make better decisions when it comes time to purchase capital equipment. I thank you for your time, and have fun listening to the rest of this webinar.
Of course, thank you. There's a lot of good information in there, and I'm sure a number of questions that would come up from that. So thank you again. Start with a few questions that kind of talk a little bit more about the braid patterns that you see most often when working with customers in the lab, and just around the ones that you use for flexibility and braid coverage for different types of things.
Okay, so yeah, the full load regular pattern, kind of like mentioned in the video, is the most commonly used pattern, especially in the catheter world. It does, have the fastest throughput, just like I was talking about in the video. If it takes the full load regular pattern 10 minutes, it's going to take the other two patterns 20 minutes. If all else is the same. As far as coverage, because the machine is fully loaded, you're using the full amount of carriers that you can on the machine. And so, when you're looking for coverage, and especially if that's your main concern, fully loading the machine, whether it's full load regular pattern or the full load diamond, is a good first step. But also just by increasing the density of the braid, by using, just increasing the picks per inch, and rise the braid angle and allow the material to cover the core as fully as needed. So I do see the full load regular pattern and the half load diamond pattern probably most commonly in the lab trials that I do. Full load diamond tends to be the most rare because of its lack of flexibility, with the other two patterns having that ability. So yeah, to answer your question, I would say full load regular and half load diamond are the two most common, with full load regular having the best throughput and flexibility.
So talk a little bit about how you work with customers in the lab. I mean, do customers typically come in to work with one machine, or, over the course of a day or 2 days, are customers able to run more than one machine, 3 or 4? How does that typically work out as you work to help them, develop those next generation applications and devices?
Yeah, so, if I'm being honest, you definitely get a lot more out of us if you make the time to come and visit. You get our undivided attention. You get to use whatever machine you want to try. When we load up, when I first am working with a customer, usually through email, phone call, we'll set up a call. We want to be as proactive as possible in preparation for the visit or in preparation for the project that we're working on. And so we kind of, based on the characteristics that they're needing and based on our experience and understanding what patterns are best to be used, we'll ask questions like, you know, do you know how many wires you want in the braid? And what your end goal is with the product. And from there, we kind of create a starting point. So, you know, before their visit, we try to have the first machine we plan to use set up and ready to go, or at least, you know, set up for us to load the material if the customer's bringing that. And just to give an example, you know, I had a customer in-house every single day last week, Monday through Friday, 2 different customers. One was here Monday through Wednesday. The other was here Thursday and Friday. And for my customer, Monday through Wednesday, we used a coiling machine, our VL400 MSI laminator, our 32 carrier braid machine in all 3 patterns, the 36 carrier machine, the 64 carrier half load, and then also our 48 carrier braid machine. So we were working very hard and making a lot of changes because the customer did not know, you know, they knew that they wanted to keep a specific braid angle, but they didn't know if, you know, the number of wires would affect their braid or if it was the size of the material they needed to change. And so there were just so many variables that they did not know because they were very much in the beginning of the process. And so we tried to get them as many samples with as many different iterations as possible.
So talk a little bit about the oven that we have in the lab. I mean, how hot does it get? How big of parts can we get into it, and that kind of thing?
So it can go to 1100 degrees Celsius. And we typically do nitinol heat setting, and we usually do it at about 515 degrees Celsius, and we'll do a 15-minute soak time, and then we'll water quench with like a bucket of water that's below the furnace. So we've heat set a few different materials before, but it's mainly nitinol.
So talk about, you know, similar to working with that new customer last week, outside of just the braid patterns, what are other things that you guys are able to do with the machines in the lab to help manipulate the performance of the braid, and that kind of thing? I mean, what are the different levers on the braiding machines in the lab that y'all help to push and pull as we look to, you know, dial in the samples and the work that we're doing in the lab for folks?
Absolutely. So it always draws down to the first question of like, what is not changeable? What cannot change about your product or your design? You know, does it have to be this size material? Does it have to be this type of material? And an example of that is like when using stainless steel, if you're using annealed versus spring temper, the annealed will be easier to work with from a braiding standpoint. You'll be able to manipulate the wire with higher tension. And the spring temper can tend to require higher amounts of tension to force that braid wire to lay down like you want. But what's better about spring temper is that it's stronger. And so like if you do some sort of braid and you want good radial force strength, the spring temper material is going to perform better. But, you know, so that's just an example, but, you know, the type of material, the size of the material, the number of wires, that's another thing. You know, in the catheter world, a lot of customers are dead stuck on 16 wires. So can it be 12? Can it be 8? You know, if you're needing a lower braid angle, or does it need to be more? Are you trying to increase your density? So, you know, that's why changing machine sizes may be an answer, changing material size or type, the core material diameter versus, or the type of core material can also play a role, whether you're using stainless steel mandrels or plastic core, or you know, maybe it's something that's actually very much going to be part of the end product and needs to be able to bond. You know, we're going to maybe laminate it and the materials are going to be bonded together. And so, you know, I would say there's a lot of different levers to pull, especially, you know, with the endless possibilities on machine size and this and that. But it really draws down to what we're allowed to change based on what you're trying to do. And then we go from there.
So in that same regard a little bit, outside of some of the core materials, different wire types and that kind of thing, talk about some of the things that you guys do with the machine, whether that's braid cones, braid formers, Paul talked a little bit about the variable density braiding and some of the controls aspects. Some of those things that levers and that kind of thing on the machines that y'all look to push and pull as you work with customers.
Yeah, so a lot of braids they really require us to mechanically manipulate the braid to do what we want to. So you can program the machine to do like a variable density, and you could go from 60 picks per inch and drop down to 30. But the problem is there's actually 4 variables that change your braid angle and can also change your natural braid point or where the braid is taking place. And that is the pattern, the size of the core, the size of the machine, and the pick count. And so those are 4 variables. So in a variable density situation, if you are, doing a drastic change in pick count, you can mechanically manipulate the braid by using, bringing the braid cones very close so that the braid doesn't, travel in one direction or the other based on, the drastic change in pick count. So if you're at 70 and then you decrease down to 30, you're probably forming against your primary braid cone at first, and then it's going to want to travel closer to the puller. So if you bring them close together, you can have that abrupt change. And just to talk on that for a second is, we can program the machine to immediately change from one pick out to the other and then mechanically actually make that a reality. But then you can also program a transition into the braid. So you would still want to bring your braid cones really close, but then if you're going from like 70 to 140, but you wanted like a 3-inch transition in between, you can program in that 3-inch transition, and the machine will mathematically, evenly distribute the picks per inch from the 70 to the 140 over the course of that 3 inches. And then the reason that would be a reality is because we're mechanically manipulating the braid. I've also done one other thing where we've added a braid disc. Sometimes the braid combs that we use is because of the braid angle and because of the amount of tension that's being applied in certain situations, we even create larger braid combs that sometimes can be the circumference sometimes of like the inside of the horn gears of the machine. And that'll allow us to really force the braid into the secondary former. And again, basically just trying to mechanically manipulate it. Another thing that braid disc does, and I've talked to many customers about it, is when you're using a lot of tension, our KLADD carriers can, the more tension you use, the more likely you can damage the eyelets in the carriers. And we'll talk about some of the parts of the carriers, but the straighter that wire can come out of the carrier, the better. And then it can take its braid angle past that braid disc or past that braid cone that we've designed. And so the braid cones, braid disc, anything like that that's just something that we can design or change in our machine shop. And like I said, mechanically manipulate the braid.
I think we've got time for 2 more quick questions. One that I think goes back to some of the information that you shared already, but one that we've got from an attendee of the webinar was kind of which braid pattern or kind of PPIs do we see most often in the lab for some different standard types of shafts that we would recommend starting to promote a flexible braid or a flexible shaft?
So I can give you maybe an example, but first just saying, it seems that I work with a different project. Every project seems so very different. And even if they are similar, they come at it in different approaches. That being said, if I were to reference the catheter world, I notice that a lot of braids in the catheter world are usually like a 16 carrier braid, full load regular pattern, 1/2/2. And the pick counts are normally between, so it's either like 40, 50, or 60. And I'll see customers, a lot of times will come to me and ask for those 3 different pick counts or around those densities to compare and see how each performs. And some customers end up really liking the high density because they're looking for a specific characteristic, and others like the low density because they're looking for a lower braid angle, but they're not that concerned about coverage. And it's more just a reinforcement thing and not necessarily that the braid is to provide much past just coverage and protection of what is braiding over.
All right, so real quick, just one last question in talking about some of the lab capabilities. You mentioned that we have a VL400 from MSI and Flagstaff in our lab. And so talk a little bit about our capabilities with that and our ability to actually reflow material for folks so we can take something off the braider, right? If we have the right materials, and we don't typically stock very much in materials because everybody wants something a little bit different. But essentially, if a customer came in here with the right materials, we could take that off the braider, we could take it over the laminator, and we could reflow it over the top of that while they're here.
Absolutely. You know, I'll be the first to say we're not the most experienced in knowing the perfect size materials and what goes with what. A lot of that does get left to the customer, and the customer is the one that we kind of lean on as far as like knowing what diameter materials to work with. So that being said, though, you know, we have the VL400, and you can do up to 4 different parts at a time. So we've had, you know, cases where we've done a braid over a PTFE core material with like a P-backs liner over top, and then we would braid over it. They would slide another P-backs jacket over top of that, and then usually a heat shrink that would go over top of that. And we would do 3 or 4 of those, and then they would, you know, maybe add marker bands or whatever else that they need to the catheter, and then we could load them into the VL400 and, you know, actually do 4 different ones all at the same time. And you can also program different temperatures, different, you know, flow rates, and then you can put a variable heat program into the machine. The nozzles on the machine, you can go up to a 1/2 inch diameter. So I wouldn't say we could reflow 0.5 inch diameter core materials. I would say anything really below that, as long as once the heat shrink is slid over, it's under that 0.5 inch mark, then we could laminate over it. And, you know, I have done recent trials where I've laminated over things that were over 0.4 inch, and it did really well. So yeah, we can go as small as you need to, and then we can go up to 1/2 inch. We can do 4 at a time, and it's worked well for a few customers, and we're starting to use it more and more.
Great. All right, Forrest, thank you for your time. We're going to move on to Will's presentation. So thank you. I'm sure there'll be a lot of questions that come up as people review the materials and think through some of the answers here. So thank you again, Forrest.
Thanks.
For our last presentation, I would like to introduce Will Huey. Will is our braiding product manager here at Steeger USA. He's been with our team for 5 years. He spent time on all of our assembly teams, was the co-leader of our lab, R&D lab, for 2 years, and for the last 3 years, our braiding product manager. Will is customer facing, working directly with our customers on their applications and equipment from the quoting stage to installation, guiding them through the process from start to finish. So take it away, Will.
Thanks, Sean. I'll be reviewing the KL80D carrier today. The KL80D carrier was designed to work with Steeger USA fine wire and fine fiber braiding machines. The carrier was designed in such a way that it could be completely broken down, cleaned, and then reassembled with ease. Steeger USA provides recommended maintenance schedule and instructional procedures for these tasks. It's really important to understand the parts terminology for the KL80D carrier. It will help in braiding discussions as well as when you're requesting spare parts from our aftermarket team. All the parts on the KL80D carrier can be removed and replaced if necessary. Some of the parts of the KL80D carrier would include the tension spring retaining bolt, the tension spring, compensation rollers, ratchet spring, carrier foot, bobbin retainer, the main carrier body, and then the eyelets. Not all parts on the KL80D carrier are wear items, but the ones that are the carrier feet, the ratchet springs, top eyelets, and compensation rollers. It's really important to follow Steeger USA provided maintenance schedules for these wear items. It will help prevent premature wear and allow the braider to run at its most efficient state. There are parts on the carrier that affect the carrier's performance. Material tensioning is very important in the braiding process, and it is crucial that the material be properly tensioned for the braiding machine to produce a quality product. There are a few parts on the KLAD carrier that can be changed to adjust the peak bobbin release tension with the various number of carrier configurations. The KLAD carrier can supply as low as 10 grams of bobbin release tension and as high as 930 grams of bobbin release tension. One of the parts on the KLAD carrier that can increase or decrease tension is the tension spring. This is the most commonly changed part on the KLAD carrier, and we offer them in a range of sizes from 0.25 millimeters to 0.95 millimeters. We get that number from the diameter of a single coil on the tension spring. Some of the tension springs are color coded, others are not. Please just reach out to us if you have any questions in regards to tension spring size, and we'll be happy to help you with that. Another part on the KLAD carrier that affects the bobbin release tension is the ratchet spring. These work with the tension spring to apply tension to the bobbin on the carrier and allow it to ratchet off. These are wear items and they should be inspected quarterly. We offer these also in a range of sizes from 0.3 millimeters to 0.7 millimeters. Our basic recommendation for these is if you're using a 1 thou round wire or lower to use the 0.3 ratchet springs, and from 1 thou to 4 thou to use the 0.5 ratchet spring, and anything higher than a 4 thou to use a 0.7 ratchet spring. The last part that affects the KLAD carrier tension is the compensation rollers. The compensation rollers act like a basic pulley system, so if you add more pulleys, there's less of a load. We offer these in standard, which is a 2-on-2 setup, 2 compensation rollers on the top of the carrier, 2 compensation rollers on the bottom of the carrier. We also offer these in a triple narrow roller setup, which is 3 on top, 3 on bottom, as well as a 3 millimeter narrow compensation roller, which is a 4 on top, 4 on bottom. The 4 on top, 4 on bottom would give you the least amount of tension of the compensation rollers. Every KLAD carrier will have at least 2 rollers on it in order to operate effectively. Thank you so much for joining us today. Now we will take some questions.
Thanks, Will. Appreciate that. And it definitely gives a good overview of the carrier, the maintenance provided for them. A few questions as far as the maintenance schedule. What typically is that standard maintenance schedule, and what is it based on?
So in our Steeger Braider manual,
Will, we're having issues. Can you pull up the cell phone beside you?
still not.
Yeah, well, there's still a little bit of issues with your cell phone. Do you want to take it off speaker mode and then just hold it up?
Can you hear me now?
Yes, thanks.
Okay, apologize for that. Well, like I was saying, in our Steeger USA Braider manual, what you'll find is the recommended maintenance schedule. That maintenance schedule is based on 24/7 operation at maximum speed. So yeah, then you would find that in our Braider manual, and it can be adjusted based on braider usage.
So if a customer is not using the machine, 24/7 and that kind of thing, are they able to work with our team to help define what that schedule can look like and should look like, depending on what their anticipated run time is and those kind of things?
Yes, absolutely. They can always feel free to reach out to us, and we can guide them in the direction that they need to go for that. There's also on our Allen Bradley IMC system a machine statistics screen where you can go in and actually look at machine runtime, and then you could break out the machine maintenance based off of that.
So a number of questions that we've gotten from the folks attending the webinar go around. How do you look to choose that carrier setup? And are there recommendations that our team can make with specific wire sizes and that kind of thing when it comes to a starting point for those carrier setups?
It's a very good question. We get that very often. So for the carrier setup, we don't really have a list that can tell you exactly where to go for each carrier setup. A lot of that's based on experience that we've gathered from our R&D lab, and working with customers through our R&D lab and also new machine purchases, we can help recommend the best carrier setup for them based on their wire size, core size, and machine size.
So if they were going to do that, they could reach out directly to you or Forrest, telling information about both the wire size and type of wire. You guys would be able to come back with them with a recommendation that says, based on our experience in the lab, this is the starting point that we would recommend, knowing that that may change slightly with a tension spring up or down or something like that.
That's correct. Just for example, we have some material in the lab right now that we've been working with the customer on who could not figure out the proper carrier setup on their machine. So we asked them to send it in to us so we could trial it in our lab to figure out the best carrier setup and to recommend that to them. So yes, they can reach out to me or Forrest, and we'd be glad to help them out with that.
So one of the things, and one of the slides that was shown in the presentation talked about different tension ranges on the machine. And so if a customer is looking to obtain a very low tension or lower amount of tension on there, talk about the difference between both the tension springs, the ratchet spring, and the number of rollers. Is there a specific starting point when they're looking for a low tension setup for the carriers?
Okay. So all three of those are dials on the carrier that you can fine tune carrier tension in. The easiest one of those to change is going to be the tension spring. That's for quick adjustments, and that's going to give you the most amount of tension increase or decrease. But for lower tension carriers, what you're going to need to do is to change the ratchet spring to our smallest ratchet spring, which would be a 0.3 millimeter. And then basically from there, you also have the ability to change the number of compensation rollers to further decrease the tension. The least amount of tension for the carrier would be to use 4 compensation rollers. That would be 4 on top and 4 on bottom. That's going to produce the least amount of tension payoff on that carrier. That would be the lowest setting that we could go on our K-Lady carrier, which has been proven to be useful on wire sizes as low as 5/10.
So we've got time for probably just one more question, consider it's almost the top of the hour. One of the things that also plays into the ability for the carriers to tension the wire correctly and everything is going to be the bobbin that we use, and selecting the right barrel size for the bobbin along with the winding that is on the bobbin. So just speak to that for a little bit. Which one of the barrel size bobbins do we typically recommend for certain wire sizes, and then also to the how crucial the bobbin winding is also to minimize breaks and carrier setup and those kind of things.
Absolutely. So Steeger USA offers 3 different types of KLADD bobbins. We have a bobbin that has a 16 millimeter barrel, a 26 millimeter barrel, and then a 30 millimeter barrel. Obviously, the smaller the barrel, the more capacity the bobbin has. Typically, what we would recommend is using a 30 millimeter barrel for most of your round and flat wires. Specifically, if you're really looking just to do R&D on the machine, we do have some customers that venture over to the 26 millimeter and 16 millimeter bobbins. Those normally have multiple ends on them, And, as far as tensioning on those bobbins, both Ulbrich and Fort Wayne work with us pretty closely to figure out the proper wire tensioning that needs to be put on those bobbins, and make sure that it correlates to the KL80D carrier payoff tension also.
Thank you, Will. We appreciate it. Considering we're right at 11, wanted to first just thank everyone that was able to attend our webinar today. You will receive a follow-up email with a link to the materials provided. Also, we would like to thank all of you that took the time to learn more about braiding catheter shafts. We hope there are takeaways for each of you and welcome discussing any additional questions, applications, and those kind of things about our equipment, our lab, or our team, and how we can help. Thanks again. We appreciate it.